Yep. Slope and rate of change problems. Okay, so this is the 2.2 continuation here. It'll be out sometime this afternoon, probably. Hopefully during 6th period, but it just depends. The next quiz. Yes, let me see. I don't remember how many sections are in this chapter. I try to break it in half. Sometime after section 4. So probably looking at maybe like next Friday. Yeah, so after section 4. So we'll do 2-3 on Monday, 2-3 on Tuesday, or 2-4 on Tuesday. So sometime around then. Probably next Friday. But we'll also probably cover another section prior to that, but like we'll probably cover 2-5 on Wednesday and then review on Thursday for the quiz. So. Alright, so obviously we don't have as much time because we went over the test and everything. So I'm going to try to go through this as quickly as possible, but making sure that we understand. So if we need to go over some more stuff on Monday, we can definitely do that. But we'll see what we can get through. Alright, so the first stuff, this is on page 86 if you are looking at it in your book. But the first set of questions says to find the slope of the line passing through the given points and then tell whether the line rises, falls, is horizontal, or is vertical. So what is true of the slope if it's horizontal? The slope is 0. How about if the slope is negative? It's falling. Slope is positive. It's rising. And if you have a slope that's like 7/0, undefined. Okay. All right. So, number 4. It gives you the coordinates 8, 9, and -4, 3. What was my formula for slope? Yep. Okay, you don't have to write the formula out like that every time. I'm just writing it for the first time while we're getting used to it, and then we'll just start using it just by plugging in numbers. So y2, and it really doesn't matter which one is which, okay, but I'm just going to call the second one y2, so that's going to be 3 minus 9 over -4 minus, oh, good, somebody caught it. Wait, no, -8, sorry, I thought that one was -2, and I was like, oh, somebody caught it. Because remember, if one of these is negative, then obviously this is going to change to a plus sign. So I thought I heard somebody say that. Huh? Okay, so the slope is 1/2. Okay, so what does that mean about our slope? It's rising. Because the slope is equal to 1/2, which is greater than 0. So that means it's rising. Because if our slope is greater than 0, we're rising. You have a question? Like if I had chosen this to be my first point? Yeah, so then it would just be 8 minus a -4 or 8 plus 4. You just have to make sure, like, if you use this as, like, your y2 and your y1, or sorry, x2 and your y2, that then you don't flip these and say, oh, well, this is, like, this is all your 1s and this is all your 2s. Don't, like, flip them mid-thing. So decide which one is going to be your set of 2s that you start with and which one's going to be your set of 1s. Sorry, I said that, like, super confusing. You all know what I mean, though. Okay. It's like my words did not come out right there. All right, let's do another one. 8. negative 6, 5, and negative 6, negative 5. So I set this up. Meaning I get what? Negative 10 over 0, good, which is undefined. Undefined, and then meaning what? Rising, falling, horizontal, or vertical? Yes. Okay, so you need to tell me it's undefined, and then also tell me that it is vertical. 12. 5, 5, and 7, 3. So how would I set this up? Yes, so 3 minus 5 over 7 minus 5 gives me what? So negative 1, and then it's what? And it's falling. Okay, do we feel like that makes sense? Are we good with that? Okay. Alright, so the next part says to tell whether the lines are parallel, perpendicular, or neither. So we're going to look at a couple of those. Okay, and the way we're going to do that is essentially we're going to take the slope of both sets of points. Okay, there's going to be two, basically it's going to be two lines that you're given, each having 2 points. And we're going to find the slope of each and decide what is happening with it. So, what is, just as a review, what is true of parallel lines about their slope? Same slope. How about perpendicular lines? Opposite, inverse of it. Good. So let's start with 18. So line 1 is 3, negative 1, and 6, negative 4. And then line 2 is negative 4, 5, and negative 2, 7. Alright, so I need to do the slope of line 1, and then I need to do the slope of line 2. So my slope of the first one, somebody set it up for me. Okay, negative 1. And then somebody set up the second one for me. Yes. Okay, it would be perpendicular. Okay, but it's not a fraction. Is it? Okay, so because it's just 1, okay, obviously it's got an imaginary, like, 1 over 1 is what's happening. So it technically is. Okay, I'm just saying that because I'm sure some of you are thinking, wait a second, they're opposites, but are they actually flipped? Okay, just remember that a whole number can be written over 1 and be a fraction. Okay, so yes, those ones are perpendicular. Let's do another one of those. Um, 20. L1 is negative 1, 4, into 5. L2 is negative 6, 2, and 0, 4. Alright. Slope 1 is what? gives me what? And my slope of 2? Okay, so same slopes here, so parallel. Okay, and if you get some that are just completely different, like if you got a slope of 3 and then a slope of 7, okay, obviously those are going to be neither. They're not parallel or perpendicular. How do we feel about this? Do we need to do any more examples of that? Okay, I'm going to try to go ahead and get in the rate of change problems, and then hopefully you'll have plenty of time to work on this. So the rate of change, it's really easy the way that they actually set them up for you. Essentially, you're literally just finding the slope and then putting units on it. So it says find the average rate of change in y relative to x for the ordered pairs, includes units of measure for your answer. Okay, so something like 24. This problem statement says that you have the point 212 and 530. Okay, and then it says that x is in hours, y is in dollars. Okay, so we're going to find the slope, and then we're just going to use dollars over hours, okay, because it's y over x for the units. Okay, so what is my slope here? (30 over 12 minus 5 minus 2, or over 5 minus 2? 6. And then now we need to put units on it, okay? So we had, remember, if you need to like do it this way, y over x is equal to dollars per hour. Okay, so then we would do it $6 per hour is how we would write that. Okay, so it's doing the same thing. Now you're just adding the units as literally the only difference in the problems that we were doing before. Yes. No. I would do it for the parallel and perpendicular ones. I would label them as like M1 and M2 like I did, but you don't have to write the M for every single one. All right, let's do one more rate of change, and then I'll let you guys work on these problems. All right, 3, 10, and 5, 18. And then X is in seconds, Y is in feet. All right, so how do I set this up? Okay, giving me what? 4, and then what are my units? Yep. Do we understand the thing with the units? Okay, I just want to make sure we're good with that. Do we feel okay with rate of change? Yes. Yeah, you can write it out if you want to. I just like to do as little writing as possible. We good? Okay. Alright, so you have actually about 25 minutes, so that's good. You should be able to get these done. So your problems are alright, 3, 5, 11, 13, 21, and 25. And those are all on page 86.